Okay, I'm going to start. So, well, Tracker, we know what it is. It's a search service for applications, which is used in GNOME. Next slide, please. We're going to start with a quick history lesson, very, very quick. So Tracker is an old project now. It started in 2005. It's not the first full-text indexer. I'm not going to talk about the pre-Tracker days. There's an interesting history if you want to do some research. But when Tracker started, it had several goals. One goal was to provide full-text search by default in GNOME. Well, that goal was achieved. Actually, it can do a lot more than just full-text search. There's a very flexible database which you can query lots of different things, but full-text search maybe is the headline. It was a goal to be fast, and mostly it is. It's susceptible to certain bugs. We try and fix them as much as we can. It was a goal to be free, and of course it's free software. It was a goal to be private, and privacy in 2005 means your data never leaves your computer. So, Tracker maintained a central search index, and it lived in your home directory, and that's fine, everything is private. Privacy in 2020 is slightly more complicated, because we now encourage users to install untrusted applications via Flatpak. So we are more at risk when we do that of leaking data. And the main motivation for the Tracker 3 version break was to try and make the database, the index, more resilient. So we have decentralized it so that we can give untrusted apps much less access. So they can still do full text search, but maybe a music app can only search through your music and nothing else. Okay, that ends the history lesson. Next slide. This is what we will talk about. We're going to start with when can we have it. Then we're going to go through what's new in Tracker 3. And at the end, of course, we'll quickly talk about how you can contribute to the project. As a spoiler, there is a lot you can contribute. So, next slide. Okay, this is... What's the name of your cat, Carlos?
This is Luis.
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 So,
yeah.
Luis wants to know, when can we have Tracker 3? And let's see on the next slide. So the good news is the core work is mostly done. Most of the core code changes were in progress already last year when we decided to do a major version break. There are lots of big changes. The database format is different and incompatible with previous versions. The C libraries are incompatible. The dbus interfaces are incompatible. So there is no way we can pretend Tracker 2 and Tracker 3 are the same, any more than we could pretend GTK2 and GTK4 are the same. We consider Tracker 3 a major version break. It's parallel installable with Tracker 2. So you can have both on your computer, but there is a catch. If you have Tracker 2 enabled and Tracker 3 enabled, they will both crawl the same files. So you will have double resource consumption, which we don't want. So you can parallel install them, but we want to make sure we don't have both running. And that means really we don't want to have both installed except for developer use cases. So it's parallel installable for testing and for us, for convenience of developers, but we expect and we hope users can migrate 2 to 3 with no intermediate stages. So next slide. Here is our plan. Our plan is to release for GNOME 3.38, which is the next major release. And GNOME releases are planned on the wiki. The dates for 3.38 mean that in 1 month, more or less, we enter string freeze when we want to have most of the core functionality ready and tested. And The harder deadline is the 5th of September. It's the last beta release. And after that, we can't really change any code. It's purely fixing critical bugs. So we have about a month in which to carry out our plan. Next slide. Let's see the plan. So, like I said, most of the core work in Tracker is done. There's only one major feature which we still want to do, which is related with on-demand indexing. So there's one more chunk of work we need to look at, but that is in progress. Most of the work remaining is in the applications which use Tracker. So we made a list on the wiki. I'll paste the link in the chat afterwards because this is an interesting page for everyone to follow the progress. And here we listed every GNOME core app that uses Tracker and every library, core library, and also some apps in the wider world which also use Tracker. And they have a tick if the port is merged, and we link to the merge request if there's a merge request. So as you can see, very little is merged yet, but branches are ready for almost every project. In fact, of the core, the only one we don't have is libfolks, which is actually unused. So although we want to port that, it's not a priority because we think nobody's using it. Nobody's using the Tracker backend. That is, they're using the Evolution backend. Rigel, there is a branch, but I think it's not public yet. Everything else we have branches. What we don't have is review and testing of all these branches. So we really, really hope that everyone watching can look at these branches. Two of the apps, I'll tell you which afterwards, two of the apps you can simply download a Flatpak and test it on your machine in a few clicks. And the others, you can review the branches. Even if you don't maintain the app, you can look through and go, I think this is crazy, or I think this is good. Every comment to say this works or this doesn't work is useful to us. So, we hope that we can get all of this done in the next month. And if we do, great, we can release everything for GNOME 3.3.8. GNOME 3.3.8 depends on Tracker 3. Tracker 2 is dead. Everyone is happy. Next slide. This is what we want to avoid. This is the Works on My Machine certificate from the Coding Horror blog. So GNOME doesn't have a formal QA team. I can test on my laptop. Carlos can test on his laptop. So it works on our machines, but we rely on you to make sure that it actually works in every situation. So we want to move beyond the Works on My Machine certificate. Next slide. We have a plan B. You're thinking now, what if not every branch gets reviewed and merged in time? After all, a lot of maintainers are volunteers. Maybe they don't have time to review these branches. So our plan B is that the core of GNOME would still depend on Tracker 2 in the next release. So that would be annoying because we'd have to ship GTK with the Tracker 2 code still, and probably Nautilus as well. Apps could still opt into Tracker 3 because of the magic of Flatpak. So the Tracker 3 miners will work inside a Flatpak bundle, even if you don't have Tracker 3 on the host. We've been testing this already, it works well. So even if we have to delay Tracker 2 for the core of GNOME, apps will still be able to benefit from all the new features by shipping Tracker 3 inside the bundle. And we recommend apps will ship Tracker 3 inside the Flatpak bundle because otherwise they won't work on older distros. So shipping Tracker 3 miners inside the Flatpak bundle means that your app will continue to work even on Ubuntu 18.04, which is never going to get Tracker 3 in the base operating system, but it can work inside the Flatpak. The cost is slightly higher resource consumption, but the upside is the app doesn't break, so I think it's a fair trade-off. Next slide, please. So a quick note for distribution packages. Hopefully lots are listening and keen to package Tracker 3. So there are two options. In the plan A I described where everything is ready for the next GNOME release, you could keep the same Tracker packages upgrade to the next major version as tracker and simply say that it conflicts with the older versions. In the case where we have to fall back to plan B and we have the core depending on GNOME 2 and the apps depending on Tracker 3, in that case it's better if a distro would ship Tracker 2 for the GNOME core to use and a version of Tracker 3 which is disabled by default but can be activated by the apps. So that will be a kind of a workaround for one release cycle of GNOME if we have to do it. So we can release Tracker 3 and we can get some testing, but it would be disabled by default, so we'd avoid the problem of double resource consumption, except when users were using, for example, GNOME Music would use Tracker 3, and in that case the music folder would start to be doubly indexed, but that's the price to pay. And it would only affect folders that app is interested in. So our recommendation, I suppose, is to wait and see. But we may, in the end, have to ship Tracker 3 in parallel to Tracker 2. It's kind of up to you. So now I'm going to hand over to Carlos, and he's going to talk about all of the things which are new in Tracker 3. So over to you.
Yep, sure. So what's new? This is Alba, by the way. And yeah, well, so the big improvement for applications is, of course, data isolation. So yeah, well, we don't require everything to be shared to everyone, and we allow certain applications to access only bits of the data, and other applications to access to other bits. So yeah, this is built on top of Sparkle language features, which sits well with Sparkle because well, it already has notions about graphs and whatnot. So they are already sets of data which we can rely on, and they are coherent by themselves, and which they have some nice features that make them quite fit for this isolation and this splitting and whatnot. And it also sits well with us because, well, we just need a small nudge in the right direction to make use of this, and it depends on the application and the queries it does. It ranges from trivial to not that much, but yeah, well, it's not something earth-shattering. And it relies on reasonably sized chunks of information, so well, it's not too cumbersome to add permissions to read music or stuff like that. So we have basically graphs which contain all of audio, all of video, and all of software and whatnot. So they are basically big chunks that applications get access to also, but not quite all of it. So here is, for example, the anatomy of a file. Maybe you know a bit about RDF and whatnot, and how it's described. It consists of triples of subject, predicate, and object, which they are basically the subject and object. They would be like the nodes in the graph, and the predicate would be an edge, which would be a directed one. So you say A is B, so that would be one set of one triple describing one interaction, and you add more and more and more, and you get a graph of things. So here is a simplification of the file, and you can imagine the graph sprawling in every other direction, and the file having different properties and pointing to other nodes and whatnot, also the video thing. But the idea here is that the file information is split from the content information and what the file contains inside and whatnot. So you have, for example, we have these big green squares, which could be the graphs. They basically separate data in between, and we have a file system graph with the file system information, and you get file folder relationship or file size and whatnot, and then you get the video graph. In this case, if the file is a video, that would contain all the logical stuff inside the file, let's say all the metadata, the title, or how long it is, or the director, and everything. So that there's a clear split between the logical data, which is contained inside the file, and the physical data, which is the file itself. And how do you do this separation? This is pretty easy on the top. Once you prepare your queries to do this separation, because if we go back in Tracker 2, this would be a single blob. The file and video would be a single element, and they would point to the parent folder and then to the director. And yeah, well, it was quite harder to split. This is using Nepomuk as it should be used. So it's an improvement, and it also plays well with us, as I said. So this is the actual stuff that makes an application talk only to one graph or the other. We specify one policy, which consists of an URI, which is the dbus name for tracker miner files, and we tell it that it can access a specific graph. So this is, I guess this is time for a demo. Let's see if screen sharing works.
I should note that this metadata is set at the time the Flatpak is built. So the app declares up front, I should only have access to music. And when the user installs it, the user can verify, right, it's a music player, it wants access to music, that's fine. Whereas if the app declares it wants access to everything, then the user hopefully will consider before installing it and will investigate a bit more to see that it's trustworthy.
Just wait a moment. I think Firefox is not liking. I tried with the test instance before. Okay, now I'll try exiting and going back, or should we go ahead?
Maybe we should go ahead. We can show the demo at the end, right?
Yeah, let's see. Hopefully.
The demo is effectively an app being unable to access something.
Yeah, it's basically that. I was just going to show that the app actually works. Yeah. So yeah, the next point it would be stores and endpoints. So yeah, this is the actual most substantial change in the tracker API structure. So before you had an store, which would be an entity you don't know what it is. And you put tracker sparkle connection get, and you get a singleton object, and you talk to something, and everyone talks to the same thing. So yeah, well, this doesn't pan out, obviously, if we try to isolate everything. So we now have a division between stores and endpoints, which would be, well, a store is a database like tracker store would be previously, and you create one with tracker sparkle connection new. And it works pretty much in the SQLite sense. You specify actually a location for that database, and it is your database. It's not shared with anyone else and whatnot. And if you want to make it public, you have a tracker endpoint, which basically makes your connection public in whatever channel there is, or you specify. There is DBus currently. The spec defines HTTP endpoints and whatnot. We are not there yet. It's about the last document we are missing to implement, but almost there. So we now have a store which is local and an endpoint which is an optional object to make it public. And then what do we need? We need to query that database. So and actually the Sparkle language ties it together with service graph patterns. This is fancy slang for the bits of the syntax that allow you to query different services instead of your own database. And it's pretty simple. It's you wrap it with service dbus something, and you do the same query that you used to do inside. You do it on the outside service. And actually, with these ingredients mixed together, we get a distributed database where everyone gets to own their data. They get to choose what access do they allow to everyone else, and everyone can be a participant, actually. And with these pieces, we have like three model applications. And we have, for example, application A, which would be the simplest one, like consuming tracker miners data. They want to look for files or, the file chooser, GTK file chooser would be a proper example of this, because it only wants to read data, it doesn't want to change anything. So there's this construct, tracker Sparkle connection pass new, which it basically works like a tracker Sparkle connection get from tracker 2, but you have to specify an explicit dbus name to this constructor. So that means that you have to talk explicitly with one service or another. In most cases, it would be tracker miners, but we hope that will change at some point. We have application model B, which it does this sample of this application would be num nodes, because it doesn't care about tracker miners data on itself, but it does use tracker for its own data. In that case, you have tracker Sparkle connection new, and as I said, this works in the SQLite sense. So you create your own private database and just go with it. And then the application model C is a mixture of both. So it actually gets to consume tracker miners data, but it also wants to store its own data. An example of this would be GNOME Photos with collections, or GNOME Music with playlists, or favorite songs and whatnot. So here, the approach would be to create a tracker Sparkle connection new, which is pretty much like the previous one. But then you have to use explicit service graph patterns, which is, as I said, is the syntax, the bits of syntax that allow you to query other services. The neat thing with this is that, you have your own local database, and you are allowed to query on it, and you are allowed to update on it. But the service graph patterns, they can only run on queries. So you can only query other services, but you cannot run updates on random services. You can only run updates on your own database. So the language syntax actually makes a read-only model that works for us. Yeah, and as Sam said before, we used to have user data in Tracker 2's database. So we need to offer some support in order to allow migration of data for whoever consider it important, or projects wanting to run migration scripts. So it's pretty much everything in place. We already have a tracker export command in Tracker 2.3 meant to help with this. and it's basically helps you migrate application-specific data into your own databases. And I think this is for you, Sam.
Yes. Okay. So that's about apps. What about users? Well, why aren't users first? Because Tracker is not intended as something end users in general interact with directly. The design is that applications or the shell will expose search results, or maybe your voice assistant, like the one Giovanni is talking about right now, can contact Tracker. But in general, if a user notices Tracker, it might be because it's gone wrong. So what's new for users? Data security is the big thing, as we've already talked about. One thing which I'm quite happy with, can you show the next slide?
Yep.
We have some online documentation. The eagle-eyed of you will notice that this is just the man pages turned into a web page, but I think that is much better than nothing. It means we keep the man pages up to date, and it means you can read the documentation of the command line without having to have man pages installed. Also, we have a website, in case you missed it. We now use GitLab Pages to put up a simple website with some instructions for people who want to find out more about the project, who want to contribute, an FAQ for people who have seen Tracker MineFS in top and want to know what it is. And we're quite happy with it. Can you go to the next slide? So talking of the command line interface, some users will want to interact with Tracker, perhaps because they have complicated use cases. So our goal is to work out of the box by default. But because a user's home directory can be enormous, it could be an NFS mount, it could be a 15 terabyte very slow hard disk, we can't do everything by default. So the default configuration of Tracker is relatively conservative. It indexes the default XDG content directories, and it indexes the home directory, but non-recursively. So that gets most data that let's say a person who doesn't have huge amounts of files in their home directory might use. But more advanced users will want to configure Tracker to do more complicated things. The command line interface is also useful for developers and for bug reporters. It provides a way to see what went wrong, perhaps if a file isn't indexed and you think it should have been. So the news is that we have done some work on the command line tool. It's now more like Git, in that we can install custom commands from different modules. We want to improve it more. So, for example, systemd has brought some quite nice improvements to command line tools, such as automatic pages, and we want all that. We want, at the moment, Tracker reports errors into the journal. We think it would be good to save errors onto the disk and be able to show them in the CLI as well, so we don't have to tell users how to dig in the journal necessarily to report a bug. And yeah, so this work is lower priority because we don't have to block the release if the CLI isn't ready. So we have plans. We haven't finished all of this work yet because we are more concerned with making sure that the API changes and the application ports are ready. But we do want to polish the CLI. And I think it's now back to you, Carlos.
Yep. Yeah, so for current developers, well, I try to split this section between current developers and prospective developers. So yeah, so what you get here is a streamlined API, as in, yeah, well, in Tracker 2 we have like 3 libraries. One, the classical Sparkle library, which is the only one staying. And then you have another one to implement miners, which no one ever used in more than a decade. And you have the Tracker miner control API, which some projects use. But yeah, well, It's not. It doesn't fit the picture as well for Tracker being a core Sparkwell thing. So basically, we've streamlined the API into the Sparkwell library, which is Tracker, the Tracker Git module. And then we have for Tracker miners, the most prominent daemon is the file system miner, and that will be your free desktop Tracker 3 miner files. Give us name and interface, and yeah, that would be the API to talk to it, to set priorities or to ask to index things and whatnot. But that's not Tracker's core task anymore. And we have better documentation. Sam did some nice work on better ontology documentation and whatnot, which could also apply for custom ontologies. And it's also better documented in that, well, we are now following the Sparkwell 1.1 spec by the letter. So yeah, well, we have a more constrained vision of what things are, so we can document things a lot more better now. It's standards compliant, so well, every Sparkwell trick you might see on the internet, it will work on Tracker. So that's a nice improvement. It's easy sandboxing. You can now run fake endpoints or run your Tracker miner FS for testing with some target files, and Sam did quite some nice job over here with improving the testing and the sandboxing of applications. So yeah, it's got easy sandboxing, which I jumped this point. Which is what I've been talking about before, these 3 lines in the Flatpak manifest, which help you listen to this portion of information or this other. And it also got better validation tools, as in, if you are a developer or using Tracker, you have better tools at your disposition, like. Yeah, you have better syntax errors, which actually point you to the place where you committed this mistake. You have also a set of command line tools that may help you to actually test your stuff, test your queries, or test your own ontology and whatnot. So it helps developers better rather than having a single central service. And if you run something to test, you better take care of deleting it properly and not to delete too much, because it's live data and you don't want to mess with your data. So you can create fake endpoints and databases in memory, everything. And it's actually still fits, as in, well, Tracker was devised got most of the development in the Nokia days, and it was aimed to work on these Nokia devices, the very old ones based on Linux. And well, it has quite some constraints that are right now like a joke, like 256 megs of memory, and I don't remember the processor, but yeah, well, and the thing is that we managed to stay quite in the initial footprint, in the memory footprint that was initially devised for those devices. So it's nice that after so many years we haven't got any further. And it's also fast. It could be more faster for updates, but well, to be honest, that's not the most optimized code. It also is more likely to run because you're not running updates all the time. You are most often querying, and it actually handles 6 million queries in 30 seconds. Everything recorded in ideal circumstances, as in trying to score out I/O bumps and and everything. But yeah, well, it gives a rough idea of the baseline that Tracker of what Tracker can do. And yeah, well, thing is that for current developers, most of them, they are using Tracker miners and they are fetching index data, so they are users of Tracker by trade because they need the index data. But what we actually have here, we think it's actually a pretty good, solid thing for storing your own data, a pretty nice solution for application data, because it's still local, it's still fast, and you get all the benefits from SQLite. Just you get the different mindset that Sparkle involves. So you talk graphs and nodes instead of columns and tables. You get actually more stuff on top. Sparkle has some nice features, as in, I don't know, being fully introspectable and whatnot. You can do. It allows pretty complex things. Even it ranges from the very simple to the very complex. So yeah, you can do services across different or queries across different services, or do backups or bulk exchanges of information between endpoints and whatnot. So it's got some benefits that SQLite that doesn't offer, and it's got new impositions. As in, Tracker used to have use Nepomuk, and this is the format of the data, and this is how you use it. Not anymore. Yeah, let's say this. Thing is that you can actually describe your own data format. An ontology basically describes the classes and the properties that the classes may have, and these properties may actually have different types or may point to different other classes. So you basically describe the relation of the data in your graph. That's an schema in the database world. So yeah, it's you can write your own and use your own data, and your own data is actually yours. It's not in a shared database readable by everyone and whatnot. And even if you wanted that, you could, for example, create an endpoint for your own application and whatnot. You could also benefit from sandboxing. This sandboxing infrastructure that we've done is actually Tracker Miner FS is one user of them, but you could be another. And this is where it gets crazy, as in, yeah, well, nothing of this is done yet, but these are kind of crazy ideas, but which are actually within arm's reach right now. So on one hand, your application does not necessarily have to stay within your application. For example, we have shell search asking for favorite files and whatnot, and that is actually a service query. Well, it could be a service query if you are an endpoint. And even if not, and if you used Tracker for your own data, like for example, Nautilus does for the favorite files, you could actually implement a lightweight search provider that just spawns Tracker and no other ancillary stuff like GTK or heavy stuff, just for the search providers in order to be as fast as possible and as fast as possible. Another thing that is kind of nice here is that, I've been talking about introspection of data and about how you can import and export loads of data between endpoints and whatnot, and we have endpoints, so data can talk between them. And this is essentially data synchronization. If we have an endpoint which can talk across the local network, we could have data synchronization about the same application into separate machines or things like that. So yeah, maybe it could open the well, it could open the possibilities to a synchronization panel in settings, basically. And another possibility is point search, saying, instead of just searching in your own machine, you could have a set of trusted machines in your local network, and you could be able to query on them if they are turned on, and you could be able to search on them or to look stuff in them, just like if they were your own. Also with virtual machines in your, running locally in your own computer. So yeah, it can go either way, even if it's used locally currently. And I think this is yours already.
Okay, yes. So the last part is how you can contribute. The biggest way you can contribute is to test what we have. So the easiest thing, there are a couple of apps. I think GNOME Music is one of the closest to being ready. And there's a branch on the GNOME Music GitLab which will give you a Flatpak bundle that you can simply install and see if it works. What it should do is index your music directory and show some music. There's also a GNOME Photos branch which is similar. That is less finished, so make sure you read the bug report before saying, oh, this doesn't work, because lots of stuff doesn't work. It gets as far as showing your photos, so that's a good step, but there is more to do in terms of porting GNOME Photos. Other apps, we haven't yet made bundles that would work on older systems, but it's something we want to do, and it's another thing you could contribute, in fact. Look at how we did it for music and photos, and you can do the same in other apps. Let's go to the next slide. So yes, you can test the apps. There is a slight bug in GitLab at the moment. It's supposed to give you a link in the merge request to the .flatpak artifact. Instead, it gives you a link to a tar file, which is not much use. So you have to, when you look at the merge request, you have to browse the artifacts and choose the one with a .flatpak extension so that it works how we expect it to. If you're interested in deeper testing, I use Fedora myself, so I've made a Copper repository where you can download my custom packages of Tracker 3. For other distributions, there are equivalents to Copper. Ubuntu has PPAs, for example, or unstable repositories. It would be great to see Tracker 3 packaged in these so that more and more people can install it and test it. Developers can review our merge requests against applications, even if it's not an app you maintain. A comment to say this is crazy or this is great is useful. And if you want to get involved in Tracker yourself, there are plenty of things, interesting things you could do. Get in touch. We're in IRC /matrix. We read discourse. And there is also, for viewers watching in the future, you can always use the help wanted label on gitlab.gnome.org and you will find some issues tagged with help wanted. Hopefully they'll be interesting. So I think that is everything. We have time for questions, and maybe screen sharing will decide to work and we can do the demo. Yeah, I'm not sure. Well, why don't maybe I can answer a question or two while you set up the demo.
Yeah, you have 5 minutes for presentation, so
cool.
Take your time. And you can find the questions in the shared notes. There is a link to the Etherpad.
Yes, I can see it. So the first question, which in fact was answered in the slides, but I'll read it. If my app is mainly distributed as a Flatpak, how can I migrate while not losing the ability to run it on other systems? So yeah, the answer is to bundle Tracker 3 miners inside the Flatpak. There's a slight trick to doing that. You have to install some custom service files, and your application needs to first query the host miner FS, and then try to query the local miner FS if that doesn't work. But like I said, it's working in music and photos, so you can look there for a reference. And good news, I think we can see the demo after all.
Yeah, exactly. So yeah, so this is running a Flatpak of Genom Music.
Could you make the font size bigger?
Oh yeah.
Much better.
So this actually works. This is Genom Music using Tracker 3 on the host, running Tracker 3 on my system. But it would work the same if I took Tracker 3 out. So, boom. This is, yeah, takes time to load the covers, but yeah, this is it. And the thing is that, well, if we try to get in there, it's also shipping the tracker command line tools and whatnot, even though it's not necessary, but for testing this stuff, it's kind of nice. So yeah. So here is I'm querying for music pieces, and this are the actual well, the made up node names for these audio files. It's actually the audio. If we can grab one of these and Tracker 3 info. Oh yeah, whatever, but you get to see information. It's a song. But you will get only to see the stuff contained extracted from the content of the file, like the average bit rate or the codec, stuff like that. This is you don't get to see nothing but the URL or the URI of the file. That's all about you see from the file content. And yeah, for example, let's try to do the same for videos for fun, and we get nothing, even though if I get into Totem, is anything. It does return stuff, which are the actual video files, which are inside in my computer. So this is about it. Not too flashy, but it shows.
Okay. So we still have some time for questions, I think. Now that we've proved that it's not vaporware, it does indeed work. Let us look. So the next question, how would distros disable Tracker 3 by default if Plan B goes into action? They would only install Tracker 3 if something links against Tracker 3. Would that be sufficient? No, my suggestion is Tracker 3... Well, Tracker is started through XDG Autostart. So if we want to disable it by default, we simply remove the Autostart file. So you'd have Tracker 2 would have the XDG Autostart file, and Tracker 3 would not have its Autostart file. So it would only be started via dbus activation, which would only happen when an app actually needed it. So it gives us on-demand activation. The next question... Oh. Carry on.
No. Yeah, well, I was going to reply to that one. Yeah, so... first of all, the question is indexing faster compared to Tracker 2? Yes and no. Well, the actual, first of all, this talk wasn't about tracker miners per se. It was about tracker, the Sparkwell thing. It's not about indexing. But yeah, well, if you ask, the indexing is, first time indexing is not that much faster because that's IO bound, and we also rely on the tracker struct side, rely on libraries like GStreamer or Poplar to open file formats, and we depend on the actual speed of those libraries to index. There's some libraries that fare better than others, basically. So yeah, well, there's some files that are bound to be slow because of the library we pick to parse those, basically. And the second time indexing, as in catching up with changes or adding the monitors in case of a startup where everything is already indexed, is actually quite faster because, well, yeah, well, we also spent some time in there. So the data split, we had the opportunity to look closer at that code, and it's actually faster. It's mostly IO bound, also in that regard, as in checking m times for files as fast as possible. So that's a plus.
I think performance in general, it's something we're quite interested in, because obviously if you make a distributed database, the performance characteristics are interesting.
Yeah, well, that's true. Well, I mean, it's got different pitfalls, basically.
Yeah, so this is one reason we really want to get as much testing as possible so we can make sure we optimize where it's needed.
Yeah. Yeah, and the next question is data portability. Something I'm very conscious at the moment is data portability, either migrating data between local machines or seeking to a cloud service. Could be either by the app or simply saving data to a location that's synced by Nextcloud, Dropbox, etc. That's what I've been talking about, these pie in the sky ideas. I mean, we already have a distribute model. We are just lacking an endpoint implementation that allows us to query between separate machines. We already have the client side because, well, you can already query, for example, Wikimedia's Sparkwell endpoint to query Wikipedia, and that works with Tracker, actually. But yeah, well, we are lacking the other side, being able to expose an endpoint through HTTP or whatever other medium. And after that, we could talk between machines, whatnot. Other mediums, other media to save the information and to forward it. I don't think it fits that well actually with Tracker. I mean, and actually, all this post is about mostly about trying to avoid remote services like for bookmarks and whatnot, data that should stay personal and not get out of your local network.
That's a very interesting question. All right.
Please go finish. You have some time.
Okay, so I think it's a very interesting question because Tracker could integrate with something like Nextcloud, for example. Transferring files is kind of out of scope, like Carlos said. I think there are already tools for synchronizing files, but synchronizing data which we store in the database, like maybe bookmarks, starred files, photo albums, this is where it's more interesting.
So I think that's all of the questions. Thank you, Carlos and Sam, for excellent presentation.